Good morning, ma'am. My name is T. Harshita from CSM. Now I am doing a CIE2 assignment, and my topic is floating point members and operations. Floating point members and operation. First, we discuss about the introduction to floating point members. Floating point members are used to represent real numbers in a way that can accommodate a wide range of values. They are essential in scientific computing, graphics, and engineering applications. The floating point representation allows for the execution of very small and very large number efficiently. Structure of floating point members. A floating point member consists of three main components: the sign, the component, the exponent, and the significand. These are the three main components of floating point member. The sign indicates whether the number is positive or negative, while the exponent determines the scale of the number. The significant holds the actual digits of the number, providing precision. IEEE 754 standard. The IEEE 754 standard is the most widely used format for floating point representation. It defines various formats including single precision 32 bits and double precision 64 bytes. This standard helps ensures consistency and predictability in floating point computations across different forms. Now we discuss about precision and range. Floating point representation from with traits of between precision and range. Single precision can represent numbers approximately between 1.4 times and 3.4 times. Double precision offers a much wider range and greater precision suitable for complex calculations. Floating point arithmetic. Floating point arithmetic includes basic operations such as addition, subtraction, multiplication, and divisions. These operations can lead to rounding errors due to finite representation of numbers. Understanding how floating point operation work is crucial for accurate numerical computations. Floating point mathematical operations are required in wide range of appended applications such as control system and digital signal analysis. Where an application does require floating point, the performance target often dedicate the need for a hardware-based floating point unit. Most abundant processor SOS offers a version that provides a hardware-based floating point. A key attribute of a floating point acceleration function associated with the processor is whether the floating point unit is compliant with the IEEE standard 754 for the binary floating point arithmetic. The precision of the floating point unit, single or double, is also an important attribute in developing the floating point algorithms. Next, we discuss about rounding modes. There are several rounding modes used in floating point arithmetic, including round to nearest and round towards zero. The choice of rounding mode can significantly affect the outcome of calculations. It is important to select an appropriate rounding mode based on the specific requirements of the applications. Now we discuss about common issues with floating point numbers. Floating point numbers can lead to precision errors, especially in iterative calculations. Problems such as overflow and underflow can occur when numbers exceed the representationable range. Awareness of these issues is essential for developing robust numerical algorithms. Best practices. To minimize floating point error, it is advisable to use a higher precision format when necessary. Avoid subtracting numbers that are close in value, as this can lead to significant loss of precision. Regularly validate result against known standards or use attributory precision arithmetic libraries when needed. Applications of floating point members. Floating point members are widely used in scientific simultaneous stimulations, financial calculations, and machine learning. They enable the modeling of real world phenomena where exact integer representations are insufficient. Their flexibility and efficiency make them a cornerstone of modern computing and data analysis. Next, finally, we discuss about the conclusion of our topic. Understanding floating point numbers is crucial for everyone working in fields that require numerical computations. The balance between precision and range necessitates careful consideration in programming and algorithm design. Adapting best practices can significantly mitigate the challenges associated with floating point arithmetic. Thank you, madam.